Okay, we're going to begin chapter 17. There are 4 sections in chapter 17. 17.1, which is what this video segment will be about, the atmosphere and balance. Subsequent videos will be 17.2, heat and the atmosphere, 17.3, local temperature and variations, 17.4, human impact on the atmosphere. Now, it is a very good idea to read through, skim through the textbook, look at the headings, read some of the key ideas, look at some of the vocabulary terms before you start this presentation. So if you haven't done that yet, go ahead and pause this video, open up your textbook, skim through the section that we're going to be covering in this video. Now, as you take notes, there are different ways to take notes. One of the first and most efficient ways I find is the Cornell method. That's where you split things up on one side of your note page. You have an area for key terms, definitions, and then on the other one you might have some questions or emphasis items that the instructor says this is very important. At the top is the title, at the bottom is a reflection. It might be answers to the section review questions, it might be a paragraph or a couple statements on what you are unclear on or need more help on. Another way to take notes is the standard Roman numeral or numerical method, and another way to take notes is just by bullets. So it's up to you. What's nice about this video is that you can stop it at any time and record any information that you need or that you hear beyond what you see on the screen. Now, the objectives for 17.1, the atmosphere and balance, there are 2 of them. The first one is to describe the formation of Earth's early atmosphere and the composition of the lower atmosphere. Next is we're going to demonstrate how the Earth system continually recycles gases such as oxygen, carbon dioxide, and water vapor, and how natural events and human activities disturb an atmosphere in balance. Some of the key ideas are the composition of Earth's atmosphere remains fairly constant. Gases move continually between the atmosphere and other parts of the Earth system, and the recycling of atmospheric materials maintains a delicate balance, and local events may have global consequences. Those key ideas are in the readings in the section in your textbook. So we're going to begin talking about the composition of the atmosphere. Now, early on, scientists hypothesized that volcanic eruptions played the main role in the forming of Earth's early atmosphere. Gases released from volcanic eruptions, like carbon dioxide, sulfur dioxide, water vapor, and nitrogen, probably made up nearly all of the entire early atmosphere. Now, oxygen may have first entered the atmosphere because of sunlight splitting water vapor molecules into hydrogen and oxygen. Now, the amounts of oxygen in the atmosphere seem to increase significantly as early life forms trap the energy of sunlight through photosynthesis. This process of photosynthesis releases oxygen as a byproduct. So, the development of the atmosphere looks like, scientists believe, it's changed quite a bit from early on till now. Now, today's Earth's atmosphere is a mixture of many gases. We call that air. Now, the 2 main gases are nitrogen, which is over 78%, and oxygen, which is almost 21%, with small amounts of other gases and dust particles. Other gases may include argon, carbon dioxide, dust particles may include soot or ash. Now, the recycling of the atmospheric materials is what remains stable and has remained stable with Earth's recent history because we have an efficient recycling system. We'll get to that in a bit. Now, there are several different materials that recycle itself within the Earth's system and within the atmosphere. There are basically 2 ways. It can go into the atmosphere, it can go out of the atmosphere. So we're going to walk through 3 different materials and how it goes into the atmosphere and how it goes out of the atmosphere. The first is CO2. CO2 can go into the atmosphere by the decomposition of organic material. If that tree dies, decomposes, CO2 is released out into the atmosphere. Another is by animals or humans breathing. We release CO2 when we exhale. Now, how CO2 goes from the atmosphere back into parts of the Earth system includes photosynthesis. CO2 is taken out of the atmosphere by the process of photosynthesis. Now we have water. Water going into the atmosphere includes us exhaling, or any animals exhaling, as well as transpiration from plants. evaporation from any body of water, in this case that river or stream, H2O goes into the atmosphere. It comes out of the atmosphere through precipitation. Oxygen, O2, is released by photosynthesis. It is taken in through the breathing. So these are examples of recycling of atmospheric materials. Now gases, including water vapor, move between the atmosphere and other parts of the Earth system. Remember, the Earth system is composed of the four main spheres. Biosphere, in this case we're looking at deer, all the plants. We have the geosphere, you can see the riverbed there, any other solid material that you see. We have the atmosphere, all the gases, and we have the hydrosphere. In this case we have the river. We also have the precipitation. Clouds can be part of the atmosphere and or the hydrosphere. The composition of the atmosphere remains fairly constant because it has an efficient recycling system. Now this is balanced. This makes it balanced. The efficient part is the amount comes in, the amount goes out. Now, for example, if you have a paper plate and you want to throw it into the recycling bin, hopefully that entire paper plate will then become another paper product. That would make it an efficient recycling system. Once that becomes inefficient, then there's an imbalance, and something will gain and something will lose. So that's what it means by recycling, an efficient recycling system. Local events can change the composition of the atmosphere with global consequences. For example, there are two main examples. First is a violent eruption. Volcanic eruption might take place in one location. Huge amounts of gas and dust are thrown up into the atmosphere. They move from one place to another, affecting other climates, and has global consequences. Another one might be the CO2, the amount of CO2 in a city that's released by the burning of fossil fuels, or if there's an increase naturally of CO2 in certain areas on the planet. All that CO2 then moves along within the atmosphere, and it can change the global climate. So those are global consequences that come from local events. One thing that we really want to look at with these local events and global consequences is that delicate balance. Now that delicate balance can be supported by evidence. And this evidence, one of the factors that can have a change in global consequences is the amount of CO2 in the atmosphere. Now, although CO2 is only 0.04% of all the gases in the atmosphere, it does have an effect. It seems to have an effect, based on the evidence, of climate. It has an effect on climate. Now, the data collected at Mauna Loa Observatory in Hawaii shows that CO2 levels have increased in the last few decades. And so this increase seems to be primarily due to the increase in human activities, especially burning fossil fuels such as coal or fuel from jets or automobiles. Now, one thing I will do is I'll put in questions. And what I'd like you to do with the question is I'll pose the question and I'll read the question. I'll take 1 or 2 seconds, and then I'd like you to pause the video and try to answer that question before you see the answer. So for example, what is the only substance in the atmosphere found as a solid, a liquid, and a gas? Pause. You can pause the video, answer it on your own, and then I'll show you the answer. Water, states of matter, solid, in snow, liquid, rain, gas is water vapor, which is what condenses to make clouds. So that's an example of a question that I would pose. Now what I'd like you to do at this time, now that we're done with the notes for this section, I would like it if you look at your section review questions and try those as practice. You can write those down in your notes, the answers or the questions, or you could just think through those. Take a minute or two to think through them before you move on to the next section. It's really important that you reflect on what you've gotten out of this video, what you've gotten out of the notes. At any point, please raise your hand or contact the teacher for more clarification on any of these concepts. Now, if we go back to the key concepts or the key items in the objectives, describe the formation of Earth's early atmosphere and the composition of the lower atmosphere. We did talk about the formation of Earth's early atmosphere. So can you can you write down what Earth's early atmosphere was like and how did it form? Another part of that is, can you write down the composition of the Earth's lower atmosphere? Do you know the main gases in the atmosphere? The second objective for this lesson are demonstrate how Earth's system continually recycles gases and how certain activities disturb an atmosphere in balance. So can you literally write down one of the recycled materials, how that material, when we talked about CO2, O2, and H2O, can you talk about how those gases go into the atmosphere? How are they taken out of the atmosphere? Second part of that objective is how certain activities disturb an atmosphere in balance. The two examples I gave were the violent volcanic eruption taking place. Can you describe how that affects the atmosphere's balance? Or can you talk about the amount of CO2 in the atmosphere and how that affects atmosphere in balance? So those are some reflective areas that we need to cover, and we need to make sure that the concepts are understood. If you're still uncomfortable with those concepts, again, please seek additional help or tutoring. And that concludes 17.1.